This is our latest high voltage pulse power source, 15 kV DC, 350 microfarad, 40 kilojoules at typical peak current of 200 kiloampere. The system can also deliver currents up to 300 kiloamperes. This is the front portion with the strip line geometry, where you can see the ground terminal and also the top terminal. The system consists of a top plate, where you can see over here a connection plate which could be removed and kept on top, an inductor, etc., and short the ends. This is the total strip line, consisting of a width of around 900 millimeter by 12 millimeter. This is the entire area which is connected to the rail gap. This is the typical rail gap, which can carry 750 kiloamperes. This is the end portion of the rail gap, which is directly connected to two capacitors, C1 and C2. This is the trigger terminal, and these are the pneumatic connections. As you can see, the entire construction is so made that the capacitor is grounded on the bottom plate. This plate is between this gap. This is the ground plate. On top of that, there is a dielectric, and this is the live plate. This entire plate goes to 15 kilovolts when charged, and hence has not to be dabbled or disturbed on it. This is the total strip line end connection. This is the dump switch. The dump switch has got also indications using a micro switch. These are the high voltage dividers, both analog and digital. This is the trigger generator and trigger transformer and decoupling capacitors. Entire wiring is done through polymerized silicon cables, and this is the dump resistor channel. This is the feeding side of the system, which consists of positive input, negative input. It's got spare control, mains trigger. It's got all the pneumatic connections, spare, rail gap in, dump in, spare, rail gap out, dump out. This indication shows that high voltage is on, it is not dumped. This shows high voltage is dumped, system is off. Two triggering systems, one is through a plus 10 volt pulse and second is through a fiber optic cable. The capacitors and pneumatics are all well connected. This is the discharge resistor. This is the other side of the equipment. To dismantle the system, we need to first open this bolts, 5 bolts and 5 bolts, and this bolts to the rail cap. The rail gap needs to be disconnected. The entire metallic structure can be then removed from top. This is the link plate where, if you wish, you can connect an inductor and short the ground over here through cables. Once this is removed, this entire top plate, black color, can be lifted off and the whole structure can be removed. With peak currents in the region of 160 kiloamperes, one can do jobs of this nature, where shrinking can be done of huge aluminium containers. This is typically done at just a voltage of 7.5 kV, 2 shorts, peak current 160 kiloamperes.